Hello and welcome. Today I'm going to go over a machine build, AVID CNC, computer numerical control, which is basically a robot that can cut things. It can do, it's a 5 foot by 10 foot machine, so it can do 5 foot by 5 foot bolted birch. It can do 4 foot by 8 foot sheets. It can do 5 by 10 foot sheets, which I've found a supplier for. So it's hopefully will come in pretty handy. I had built a CNC machine, I don't know, 5 or 6 years ago with a 3D printer and some conduit, and this is kind of the picture of it here. And I basically, that was a fun project. It's called a mostly printed CNC, MPCNC. So I followed. It was originally, there's a website. It's a free thing to build. It only costs really, I think it was around $600 for this build. I had done some improvements to it over the years, added a different Arduino board with some different custom stuff. But yeah, this is the original thing that I had. So I kind of knew a little bit about it, but not entirely. And so I should apologize in the first place on the video. As you can see in this picture here, I've got some security cameras set up, and I thought I was going to have all the different cool angles to have a cool build video showing everything. I couldn't extract these videos for the life of me. So what I thought was going to be cool ended up not cool. But I did have some random phone footage, and I did have some random images that I did. So I'll do kind of like a little bit of a collage on that. Basically how this all started is I started playing a real cash video game about 20 years ago after a brain injury. Kind of a way to get my mind back into going. I had lost like 90% of my memories. I had a bankruptcy that had just started and it lasted 10 years. I had gotten divorced. I had 3 kids with child support. I was on food stamps. It was a mess when I started the game. I really didn't have anything at all really to lose, let alone play with. But it's a real cash economy game that I started called Entropia Universe. And my buddy had explained that somebody bought an asteroid for $100,000 in a video game, and I thought that was a cool idea. So I started playing, got pretty lucky with starting out. I had some good luck, and then kind of got the feel for the economy. I started learning how to code, started making some software to analyze the economy, analyze the different markups and all this stuff to kind of help me figure out the best way to make the money. And so that worked out pretty good. I built some software over about 10 years to help me with that. And then I built like the largest blueprint collection in the game. One of the largest, probably the largest. And then, so I could pick my markups. I could pick, basically whatever's not being filled, I can fill the need, fill the gap. So it's worked out pretty good. It bought this machine, which is a $30,000 machine. It bought a condo. It bought... And, a combination of the money that I take out of it, I've reinvested in stocks or real estate or things like that. But overall, it's steamrolled into pretty impressive in totality at this point, which is just surreal because it's just a video game basically that I owe all of this stuff to. So anyway, that's the background of how the machine got started. So once again, apologize for the video. I'll go ahead and start this going here. I may have to stop it if because I'm using Blender, and I was trying some new fancy like geometry nodes things with the text, and I didn't really get all of what I wanted to do. So we'll see how it turns out. I may redo it. But there's a couple of text effects I wanted to add in. I probably won't get to it. Just because I want to get this done. It's taken me like 3 days just to get to this point. So here it goes. We'll get it started. And then I'll kind of explain what's going on. So originally I started out with basically clearing out one bay of my garage. And then I took everything off the wall, painted, and then this is me painting. I had already done the ceiling entirely for the garage with a sprayer. So that's all done. And then I only did these walls mostly because when I started the paint, I hadn't ordered the machine yet. And then when I ordered the machine, what was saying 6 weeks, they said, oh, we can get it to you in 2 weeks. So it was like a big rush of like, oh shit, I gotta get this stuff ready because I had no power. The paint still needed to be done, so I basically just got this wall and everything around the machine done. And then this is just kind of me finishing it all out. And then the components all came in a bunch of packages, as you can see here. And it's really heavy. It was like 1,400 pounds, I think it was overall. But a lot of heavy stuff, but really, really well documented and marked, things of that nature. So this is kind of like how the components are packaged. There's just a lot of fasteners and things that you have to attach to the extrusions. It's really straightforward once you have the instructions in front of you, so I'm not going to bore you with all of those details because it really is kind of straightforward once you get the setup. The grease gun failed on me, but they replaced that. The support is excellent. And then basically, so that was components. Now we're into dust collection. I had added foil tape around on both sides, and then also through that rubber seal, and then I attached it with copper, and then it's actually doing really well. These are really staticky when you buy them, and there's no dust building up in them with this setup. So I'm pretty happy with how the anti-static worked on that. But I wanted to also make sure to get this overhead dust collection thing going before I built the machine, because I didn't want to have to get up on the machine or have to work around the machine. It's 5 foot by 10 foot. So, and then this is the power. I had some extra cables, so I went ahead and ran it. I had an electrician come out last year, and we did a new power supply in there. And then I had him come back and finish all the connections. So I ran the wire, and then he connected it later. And you can kind of see how the dust collection is working there. But this is me in the frame. It's pretty simple to do. I just do it with sawhorses to get the two sections together. That's the biggest, probably trickiest part, is to get the two sections together without just by yourself. But as you can see, it's doable. And then the cross members go into the frame where the gap is there. And there's just a bunch of those. I forget how many it is for this machine. But it's just a lot of little parts you got to assemble together. And then it's like Legos, slip it in. And now I kind of did screw up on a couple of the measurements weren't exact the way that they probably should have been. I tightened them all, but some of them were off. So I had to redo my software for the Spoilerboard because some of the cross members weren't going to line up if I didn't. And I redid the Spoilerboard kind of on my own. But this is the cross members in there. You can see works out pretty good once you get them all tightened up and lined up. And then the rest of it is actually pretty easy too, because you've got the gantry starts going on after that. You get the cross members in there, and then there's like dust covers and like the bumpers. These are the dust covers. The only problem I had was this one side where that pole is over there. It says to start with a short one in the back, but you have to start with a long one in the back for the screw hole to line up with the bracket that connects the two frames together. That was the only modification I had to make there. And then, the gantry itself is pretty heavy, but really not too bad by yourself, just because it's not, it rests on those two sidebars there. So once you get it on there, it's not that bad. But yeah, things lined up really well. As you can see here, here's the linear rails I've got on all the sides there, and then this is the electronics. These motors are massive, but straightforward, really straightforward, just putting all the mechanics together. Just a lot of screws, making sure everything's tight. Spindle going on there. There's the cable rack. There's some sensors, making sure that those are all lined up. And then this was the one issue I had, and I'm going to pause it there. This is the one issue I had, which was, oops, not the image I wanted to grab. Anyway. So as you can see here, originally, the way I had it set up, everything was perfect, and it was running, and then all of a sudden this cable rack hit the pole. And it wasn't even powered up at this point, but just pushing it through was like, oh, do I need to move the whole, because it's heavy at this point. And then how do I shift it just an inch and have it, still line up and everything. It's a little frustrating. But really the solution was to just there's this one link at the end which allows it to flex. And instead of doing it at these mounting holes, I just drilled 2 new holes in the next spline over and then mounted it there. And that cleared it up just fine. So, just kind of something. And, I'm sure that other people aren't going to be this close to the side of the pole like I was, because it's really cutting it close there. But just in case, it is a workaround to where you don't have to move the machine. And as you can see, I got it to where it's moving back and forth again. And still power wasn't here at this point because I had to wait for him. But there's me kind of working out how I was going to do the rest of the dust collection. I was going to come up with a whole swivel thing. Turns out some bungee cords really works and does the trick. So yeah, there's the frame, all is set up. I've got this is a touchscreen setup. And it works out really good for the control software. I've got all the cables going overhead and back down to the machine. And then this is, just things getting powered up. I used to run cables for a living, use big, massive trunks, a lot bigger than this, for server rooms and stuff. And then, so I kind of had fun with the cabling. And then the spoil board. How I did the spoil board was quite a bit different than I've seen online. What I did was threaded inserts from the underside. I've seen some guys do threaded inserts on the tops. I've seen some guys do originally how this was supposed to be is in that extrusion there. You can see that there's a channel in the top, and there's supposed to be some little bolts that you put in there, and then it screw into the top of that extrusion. But you can't do the extrusion on the side that way because it's covered by the dust covers. So I didn't like the fact that it was only using the cross member bars for support. And so what I wanted to do, and the fact that the brackets, if you want to do a custom bracket, like if you want to buy the 80/20 brackets that are meant for this aluminum stuff, it's like $4 a bracket. And if you're doing for each little opening, like I think it was like, I don't know, it was 7 brackets for each little opening, I think it was. Then, that's like $30 for each opening. It's $150 in brackets. So I went to Home Depot and I bought these brackets for, I think it was 4 for like $3. So it's less than $1 a bracket. The only thing I had to do is, you can see there's one big hole and one small hole. So I had to drill out the big hole on the outside, like you see there for the top, and then the one with the screw going into the side, I had to drill that one out too for that, because that screw was too big for that small hole. So there's 2 drills I had to do, but it's basically for a less than $1 bracket and 2 drills and 2 holes to drill. I thought it was a pretty good no-brainer to save some money. But the big thing that I like about this also is that the way that the brackets lined up is, you can see here's a better image, is that it's allowing the cross members or the side rails to actually serve as part of the structure. So it's giving some shear resistance kind of to where the frame hasn't got some kind of movement on those sides there. So yeah, that's kind of how the brackets look like from underneath. So it was a little tricky in the software, but it was a good practice. And I really don't regret it at all. Because as you can see there, the first run I was off by just a hair. But I took like a basic board and kind of figured out which size hole I used, like off like by 1/10 of an inch. So I used like a 0.33 hole and a 0.34 hole and a 0.35 hole, just to make sure to see which one would hold the threaded insert the best. And then also I had to make sure, how far from the bar it was going to be. So I had to remeasure all the cross members to make sure they were very, very accurate, so that I could get those holes to all line up on the back side. But once I got the measurements right, and once I got it into the software, it's basically I flipped the board, lined up the rails on it, and then made all the holes based off of that in the Vectric, just kind of going off the edge to relative value off of that. So it worked out pretty good, but it was a learning experience because the Vectric is a new software for me. I basically had to reconfigure the whole spoiler board, but it worked out really good. It's really strong. It's holding well. Everything's surfaced great. There's no shift at all in it, so I'm really happy with how it is. And I still have about, I think it's 3/8 of an inch before of surfacing ability before I have before I even hit one of those threaded inserts, because it's from the underside. That's the one thing I don't like about anything on the top side. If it's got a metal insert and the bit hits through it, you could damage your bit. You can screw the table alignment. There's all kinds of things go wrong when you hit metal. So that's why I don't want to have too much. I don't want to have metal in the top. So basically, we'll continue here. So yeah, that's the brackets worked out. I'm really happy with how it worked out. So you can kind of see how, you know, they take that board and flip it over and then screw it in. And then this is kind of going quick here because I didn't really have a whole lot of footage. But I redid the dowel holes also. Basically what I did is I did every 2 inches, but they're lined up to where if there's a 2-inch grid on here, the dowel hole is going to line up right on the edge of the line. So instead of being center on the line, and then you know, if you're using the grid line and you put a dowel hole in the center, everything's going to be off by the half of the dowel width, right? So I've got half of it shift over on one angle and then half of it shift over. So once I carve in a grid, I'm not sure if I want to carve it in or just draw it in with like a pen, make a pen attachment, or just put a pen in the spindle and have it, you know, draw. That's probably how I'll do it. But it was a little bit of a custom deal, and I really like how it turned out, because the first project I had is just absolutely perfect to be able to just, all I'm using is wood dowels with this. Now sometimes I can use some tape, but the wood dowels on the 2 sides, and then the other 2 sides I've basically got wedges. So I'll wedge the 2 sides in, and that holds the board in to where you don't have to worry too much. If I'm using an upcut bit, then I'll probably use the tape on the underside of it. But so far, everything that I've cut has been really solid, so I'm really happy with the setup. I don't have to worry about hitting metal. I don't have to worry, you know, if it's a wooden dowel that I hit, it's no big deal. The wedges that I use are plastic. So it's a really simplified spoiler board setup. And then I'm sure you'll see more as it goes on. But this is kind of the back of the machine. I'm not quite sure what to do. I was thinking about building like a tool tray in the back there where that space is. Yeah, and then this is kind of the machine running through the spoiler board, cutting it all. So I didn't have a whole lot of footage of things cutting just because I was, you know, it's like the first time I've really run the machine. And then this is it cutting them with the dowel system I was just telling you about. And then that's about it. So yeah, I appreciate you watching. If you have any questions, throw them down in the comments and stuff like that. I'll try to get to them. I'm not the best at getting back to that stuff just because I try to keep busy with random Blender stuff or the build or designing something or, you know, playing a game or whatever it is. But yeah, hope you have a good day. AVID CNC, it's an awesome machine. I'll do more videos on things that I make with it. Hope you have a good day. Thank you.